Newton's second law of motion worked examples. Now we know that acceleration is the rate of change of velocity. This means that when an object is in motion and it is such that its velocity is changing as it moves, then the body is said to be accelerating. Now a body can only accelerate when it has a resultant force acting on it. That is, if you push an object with a certain force and the object will accelerate. Now if you push that same object harder, that is, if you use a bigger force, it means the object will accelerate at a higher rate. This only serves to show that there is a relationship between the force that I am using to push the object and the acceleration with which it moves. Of course, if the object in question is light, it will move more quickly. However, if I use the same force I previously used on a light object on a heavier object, the heavier object will definitely accelerate more slowly. This brings us to the conclusion that the force that I am using is having a relationship with the mass of that object, and it is also having a relationship with the acceleration. Now, this relationship between force, mass, and acceleration was derived in our previous video as F is equal to ma. F being the force in newtons, m being the mass in kilograms, and acceleration being in meters per second squared. So in this video, we shall use this very relationship to work out some problems. This is Kisembo Academy. We are being told that what net force is required to accelerate a car at a rate of 2 meters per second if the mass of the car is 3,000 kilograms. So of course, using our relationship, we know that F is equal to mass times acceleration. Now we are being asked to find the force. What is the net force? That is what is required. So to find this force is going to be equal to the mass. Now our mass is 3,000 kilograms, multiplied that by acceleration, which is 2 meters per second. And of course our answer here will be 6,000 kilograms. This mass is in kilograms, this is in meters per second squared. So kilograms meters per second squared, when those two are multiplied, they give us a newton. So this is 6,000 newtons. Now take note that when we are dealing with this kind of relationship, force is equal to ma. For us to qualify this answer to be in newtons, we have to make sure that the mass is in kilograms and the acceleration given is in meters per second squared. Now, if these parameters of mass and acceleration are given to us in any other units, let's say mass has been given to us in grams and acceleration is given to us, let's say, in kilometers per hour or something like that, it would mean that first we have to change those parameters to the required units. Regardless of what unit you've been given in the question, you have to make sure that the mass you're operating in is converted to kilograms or is in kilograms, and the acceleration is in meters per second. It is only when mass is in kilograms and acceleration is in meters per second squared that the answer you get will qualify to be written as 6,000 newtons. Why? Because 1 newton, again from our derivation in the previous video, 1 newton is equivalent to 1 kilogram per meter, 1 kilogram meter per second squared. We'll go on to our next example. What is the force required to accelerate a bowling ball of mass 10 kilograms at a rate of 3 meters per second? The rate of 3 meters per second squared. This is the acceleration. This is the mass. We're being asked to find the force. So we know that force is going to be equal to mass times acceleration. That's going to become mass is 10 and it's in kilograms. Multiply that by the acceleration, which is 3 meters per second squared. And we shall end up with our answer as 30 newtons. So moving on to our third. This is more like the previous ones. We're being told that Tim has a car that accelerates at 5 meters per second squared. If the car has a mass of 1,000 kilograms, how much force does the car produce? Again, force is equal to mass times acceleration. This question is more like the previous ones. Our mass is 1,000 kilograms and our acceleration is 5 meters per second. So definitely when you multiply those two, you're able to get the answer. I will leave you do that for yourself as you go into the next number. Now in this question, we are being told that what is the mass of a falling rock if it produces a force of 148 newtons. Now here we are dealing with a rock that is falling. And what do we know about this rock? They want us to find the mass of the falling rock. It is producing a force of 148 newtons. So if we look at it, force is equal to mass times the acceleration. The force it's producing is 148 newtons. 148 newtons is going to be equivalent to the mass which is being required of us in the question. They're asking us the mass, so it is m we are looking for. Multiply that by the acceleration. Now the question does not state the acceleration anywhere. But if you look at the question, it's telling us that what is the mass of a falling rock? It means that it is falling from above towards the earth. Now if a rock is falling, it means that it is falling under the influence of gravity. And the acceleration, it means, and gravitational attraction has got a certain force. The acceleration due to gravity is a constant, which is either 9.8 meters per second squared, or if you round this off, it's 10 meters per second squared. Now in most of the questions that you'll be asked or examinations, they'll always specify what figure to use. You can either use 9.8 meters per second squared or 10 meters per second squared. Now this one, since this one is falling, it is a rock that is falling, it means it is falling under the influence of gravity, and so it means that the acceleration we shall use here will be the acceleration due to the influence of gravity. And this acceleration due to the influence of gravity, we shall use 10 for this case. So it is m times 10. So this is going to become 10m is going to give us 148 newtons. When we divide both sides by 10, this will go with that. We shall remain with our mass as when we cancel that 0, this decimal point moves up to there, so we shall remain with 14.8. So our mass here is going to be 14.8, and that 14.8 is in kilograms. Again, please take note of the units. The mass is in kilograms. It is because, look, this is in newtons and the acceleration is in meters per second squared. We'll get to our next number. In our next question, you are being told that what is the mass of a truck if it produces a force of that? So it's producing a force of 14,000 newtons. So the force produced is 14,000 newtons. While accelerating, its acceleration is 5 meters per second squared, and they're asking us to find the mass. Again, we shall say that our force is equal to mass times acceleration. Our force here is 14,000, is going to be giving us our mass, which mass we are being told to look for, m, times our acceleration. It's accelerating at a rate of 5 meters per second squared, so which is 5 meters per second. So this becomes 5m is equal to 14,000. When we divide both sides by 5, our value of m in this case is going to become by 5 once by 5. So our mass in conclusion is going to be 2,800 kilograms. In this question, you're being told that what is the acceleration of a softball if it has a mass of 0.5 kilograms and hits the catcher's glove with a force of 25 newtons. Now we are having what is the acceleration of the softball. So they want us to find the acceleration of the softball. And what are the parameters of the softball? It's having a mass of 0.5 kilograms. So if F is equal to mass times acceleration, we want to find the acceleration here of a softball that is having a mass of 0.5 kilograms. So this is 0.5 kilograms. Multiply that by the acceleration which you are looking for is equal to, the force is 25 newtons. Now of course this is the same as saying a half A is equal to 25. Now when we multiply 2 on both sides, our acceleration is 50. So meaning our value of acceleration there is 50 meters per second squared. And in our final question, we are being asked, your own car has a mass of 3,000 kilograms. If the car produces a force of 5,000 newtons, how fast will it accelerate? We are being asked to still find the acceleration. Again, it's the same as before. Force is equal to mass times acceleration. We are being told that the mass of the car is 3,000 kilograms, so this is going to be 3,000 kilograms multiply that by the acceleration. Now the acceleration of this car is what we are required to find, because we are being told that how fast will it accelerate. So we need the acceleration, and this is going to be equal to the force. They are telling us that the car produces a force of 5,000 newtons, so this is 5,000. Now definitely this is going to become 3,000. A is giving us 5,000. When you divide both sides by 3,000, we shall end up with our acceleration as 5/3, that is in meters per second squared. And that's it. If you have any issues with any of those numbers, or there's anything that is not clear in these few worked examples, please let me know in the comments below.